Today's video, I'm going to be taking a look at Venn diagrams and subsets. So first of all, a subset, the symbol for subset, I'm going to do the best that I possibly can here. It's this. It's like a sideways U with a line underneath it. That's a subset. So we would say subset as A is a subset of B. So A is a subset of B. So the first one, A, being a subset of B. Let me redraw that second one. So it's like more like a sideways U. I'm going to do the best I can. But if you're not new to the channel, you know my handwriting is not the greatest. So I'll do the best. So for example, let's say a set of X such that X is a day of the week. And let's call the set B Friday and Monday. So 2 days of the week. We would say B, sorry if I just hit the microphone, B is a subset of A. B is Friday and Monday are elements within the subset or within the set of A. A is the days of the week. The set Friday and Monday, those are days of the week. So therefore B is a subset of A because you could take Friday and Monday out of the set A. That's a subset. A would not be a subset of B because B is the set Friday and Monday. So you can't say the days of the week out of Friday and Monday. Friday and Monday are just days of the week. So letter number one, the A. X is a video game. X is such that X is a video game. B is a set of Horizon Zero Dawn, Into the Breach, and Bully, like 3 of my favorite games. That means that B would be a subset of A. It's not always going to be B a subset of A, like the second element, or the second set is always a subset of the first. Like, just make sure you understand why are we saying B is a subset of A, because B are elements within A. A is a video game, so B is a set of video games, so therefore B is a subset of A. Number 2, set C is a set of reading materials at a library. C is equal to book, magazine, and newspaper. List all subsets of C. So all the potential subsets that we could pull out of the set C. The first one would be the set itself. The set itself is a subset. So book, magazine, and newspaper. I'm just going to try to shorthand this as much as possible. That's one. Next one, we can say book and magazine. That's a subset. I could pull 2 elements out of that. What else? We can take book and newspaper. We can take magazine. Let me move this down a little bit. Magazine and newspaper. So I did all 3, book, magazine, book, newspaper, magazine, newspaper. What else? We can take each individual element. So book, magazine, newspaper. So it's 1, 2, 3, 4, 5, 6, 7, and the last one would be the empty set. The empty set. So there's 2 ways of notating the empty set. Is just 2 bars, the brackets, or you could say that. So this is counting as 1. I'm just showing you 2 different ways you can notate the empty set. So those are all the subsets of the set C. C being a book, magazine, and newspaper. So all the subsets of set C would be everything there. All 3 elements, 2 out of the 3, and there's a couple ways we could do 2 out of the 3, and then each individual one along with the empty set. Proper subset is notated as this, A, and then that sideways U without the line underneath. So A subset of B. Let me actually change colors here. If, and I just wrote is, as I was saying if A is a subset of B and sets A and B are not equal, so it's a proper subset if A is a subset of B and set A and B are not equal. So letter A, guitar, bass, drums, and vocals. Then the set B is guitar and drums. So B is a subset of A, and it's not the same subset, or it's not the same set. It's not equal. So we'd say B is a proper subset of A. It's also a subset, but we're looking at proper subsets right now. It would be a proper subset because it is a subset of A, and it's not equal to A. Number 4, represent the relationship between the two sets. We have the set W, subject in college, and then the subset Z, the set Z is calculus, physics, English, and history. So calculus, physics, English, and history are all subjects within college. So we would say Z is a subset of W. And we could also say Z is a proper subset of W because it's a subset and it's not equal to, because there's more subjects in college than just calculus, physics, English, and history. There's biology. There's college algebra. There's tons and tons of subjects. So there's more. It's not going to be equal to that. Number 5. A is Ford, Honda, Ferrari, and B is Subaru, Tesla, Hyundai. One of them are all the cars that I own, Ford, Honda, and Ferrari. I'm just joking. But this one would be neither. Neither because Subaru, Tesla, Hyundai is not a subset of Ford, Honda, and Ferrari. Same thing other way. Ford, Honda, Ferrari are not subsets of Subaru, Tesla, and Hyundai. So that would be neither. I don't like number 6. I prepared this one and I was literally right about to hit record and I'm looking at it and I'm like, I don't like that problem. I don't like the way I drew that out. So I'm going to ignore that one for now. I'll probably make another video at some point, maybe to accommodate that a little bit more, but there's something there that I'm like, I don't like the way to explain that one. The number of subsets of a set and proper subsets. So we're trying to formulate like how many subsets are there within a set. So we have the set A is pen, pencil, and marker. Let's just first write out all of the subsets of that set A, pen, pencil, and marker. So we could have a pen, pencil, and marker. So all 3 elements, just like how we talked about with the library question. Pen, pencil, and marker. That's one. We could have a pen. We could have a pencil. We could have a marker. We can have a pen and pencil. We can have a pen and marker. We could have a pencil and marker. And what am I missing? The empty set. The empty sets. Now I have all of them. So here are all the subsets. We have 8. There's a rule here we could follow. I have 3 elements. If I take 2 to the third, what is 2 to the third? 2 to the third is 2 times 2 times 2, which is 8. Look at that. I have 8 subsets, and my value of 2 to the third is 8. So there's a rule there. The rule is, if we take 2 to the n of A, we get the amount of subsets. If you take 2 to the n of A minus 1, this will give you the number of proper subsets. Because remember, proper subsets are subsets, but not equal to. So the only set that we're not counting, the reason we're subtracting 1 is because we're subtracting off the set that is the set, the subset that is the set. So pen, pencil, marker. So there's 7 proper subsets because you have pen, pencil, marker, pen, marker, pencil, marker, empty set, but not the pen, pencil, marker because that is the set. That subset is the set. So there are 7 proper subsets. So in this case, it would be 2 to the third is 8, and then 2 to the third is 8 minus 1 would be the amount of proper. So that's the rule. It's always going to be 2 raised to the power of however many elements are in this as a cardinal value. So heads, tails on a coin. 2, there are 2 elements, so 2 to the second is 4. So I should have 4 subsets. And let's just go through these. This is really short, so I have no problem just counting these off. I could have heads, I could have tails, heads, tails, or tails, heads, it's the same thing. And then the empty set, so that's 4. It's not saying like flip a coin first and then it's just saying what is the set of heads and tails. You could have heads, tails, heads, tails, and then the empty set. And then the set C equal to C, that would be, there are 2 is that value. There's 1 element, so 2 to the first would be 2, because you could have the set C. And you could have the empty set, so there's 2 subsets, C and the empty sets. Determine the number of subsets of the sets. And then we have Aloy, Nathan, Ratchet, Laura, and Peter. That has 5 elements, 1, 2, 3, 4, 5. So that'd be 2 to the 5th, which is 32. I'm not going to write out all 32 of them. I like to use these examples though as a way for you to see that visual of like, oh, it's just, that makes sense why we're getting 2 to whatever power. That ends up being however many subsets. And you can see that a little bit clearer when the sets are small, 3 elements, 2 elements, 1 element. But with 5 elements, like 32 combinations, I'll probably forget one and miss a couple. So just, there it is. Venn diagrams. Venn diagrams are really cool. Venn diagrams let U equal the council's students own in a college. In a college. Oh, I rephrased that really weird. Council's students in a college own. So council's students in a college own. Set A is students that own a PS5. Set B, students that own an Xbox Series X, which isn't many because they don't really sell well. So a Venn diagram would be, we have the set A. Then we have the set B. So set A is the set of the students that own a PS5. And then set B is a set of people that own an Xbox Series X. We also have to designate that the universe here, U, is equal to all councils. So U equals councils, students in a college own. So A and B. Now there's a lot of information that can be gathered from a Venn diagram. Let's talk about that. Intersection, union of sets. So the intersection I wrote the C, but then my marker didn't pick it up. So let me try it again. Intersection. Okay. Intersection is notated like this. It's like an upside, it's like an arch. Essentially, I was gonna say upside down U, but it's an arch. So this is the set of both people that own both a PS5 and an Xbox. So that's the intersection between the two. So in this Venn diagram, it would be this overlap here. Let me grab my highlighter. So in the overlap here would be this. That would be the overlap, people that own both a PS5 and an Xbox. So then this set A, set B, these people right in the middle own a PS5 and they own an Xbox. That's the intersection of the sets. The union of a set, the union, it's just a big U. That is PS5 or an Xbox. So they could have one, just PS5. They could have an Xbox, or they could have both. It says or. So PS5 or Xbox. So one or the other, or both. So in the Venn diagram, that would be everything. It'd be the entire it would be the entire circles, set A and set B, because it could be one or the other. So A or B. It could be anybody in that highlighted space. Now, there are things you got to be aware of when we're looking for the union of two sets, because, and this is getting a little bit ahead of myself here, but if I say set A plus set B, So let me do that again. Set A plus set B. See what I just did? That section in the middle, I highlighted twice. I highlighted with my black marker, and then I highlighted with the pink marker, but I did that middle section twice. So it's something to keep in mind of. It's not important right now, but I'm introducing that concept right now of when we have the union, we're counting that overlap twice, and we have to do something there. Next definition, complement of a set. So the way the notation for complement of a set is it's like an exponent C, but A, C. Or another way to notate this is or A with like an apostrophe. Or a tick mark. So the complement is X is in the universe of whatever we're talking about, such that X is not an element of A. So we have the set A. The complement of set A is everything else in that universe that's not A. The best way to describe it, let's just jump into an example. The best way to describe this. So the universe is faces of a dice. So let's just talk about faces of a dice real quick, just so we know. 1, 2, 3, 4, 5, 6 faces of a dice. The set A is the even number faces. So that would be like 2, 4, and 6. The complement would be all of the faces of the dice that are not in set A. So the faces of the dice are 1, 2, 3, 4, 5, 6. Set A is the even faces, so 2, 4, 6. So what would be the complement of the even faces on the faces of the dice? It would be the odd values, right? So 1, 3, 5. That's all the sides in the universe that are not the even faces. So that's the complement. And together, that set A and the complement of set A, put those together, you should get the entire universe, because those two things together makes up the universe. The set A and the complement of set A is the entire universe. So that's the complement. So another example. Set the universe is the S, such that S is a superhero. And in set B, we have B is Batman. Find the complement to B being Batman. Okay, well, if we have the universe is all superheroes, and we're saying a single set is Batman, then the complement to Batman would be all superheroes not Batman. Because that's a complement. If the universe is superheroes, you have Batman, everybody else, not Batman, but Batman plus everybody else, you get back that set of superheroes. We have this universe of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have the set 2, 5, 9. The complement of that set then, the set is 2, 5, 9. In the universal set, we have 0 through 9. So 2, 5, 9. So that means the complement would be 0, 1, 3, 4, 6, 7, and 8. So everything else, not 2, 5, and 9, out of that universal set. Plug in my computer here. All right, last example, I should say. I can't use the word set when we're talking about sets. So we have the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is 1, 3, 5, 7, 9. Set B is 2, 3, 5, 6. Set C is 1, 7. So number 11, find A intersecting B. So we want A intersect B, the overlap between A and B, all the common ground between A and B. So A is 1, 3, 5, 7, 9. B is 2, 3, 4, 5, 6. So A intersecting B What elements does A and B both have in common? They have a 3. What else? They have a 5. Anything else? Well, they have, this one has a 7, this one doesn't, this one has a 9, this one doesn't, this one has a 6, A doesn't. So the intersection between A and B is 3 and 5, because that's the only values that they both have. Find A union B. So put the sets A and B together. We're unioning them together, so we're putting them together. So that's going to make up all elements, and we don't want to repeat elements or anything like that. So we just write it once. So we have 1, because it said A. Let me erase my previous little markings here. So we're doing A union B. So A has 1, B has 2, A has 3, and they both have 3. B has 4, A has 5, they both have 5. B has 6, A has 7, A has 9, and then B is out. So we're done. So that's A union B, putting both sets completely together. Number 13. Find A intersecting the complement of B. So before we figure out A intersecting the complement of B, we first need to figure out, well, what is the complement of B? B is 2, 3, 4, 5, and 6. The universal set is 1 through 10. So the complement of B would be everything that's not 2, 3, 4, 5, and 6. So B complement would be all the elements in the universal set that is not 2, 3, 4, 5, and 6. So that would be, I'm trying to keep this all on one screen. Oh, okay, I can fit it here. So that'd be 1, 7, 8, and 9, right? Because B is 2, 3, 4, 5, 6. Universal set would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and 10. Almost forgot 10. Good thing I went back and checked. So now we have A intersecting B complement. So now we're going to look at A intersecting with this new set that I just came up with, this B complement set. So A is 1, 3, 5, 7, 9. Let me write A over here so I don't have to keep scrolling up. So A is 1, 3, 5, 7, 9. So A intersecting this new set of B complement. They both have a 1. This is 7, 8, 9, 10. So 7 and 9. They both have a 7. They both have a 9. So there's our overlap. The intersection is the overlap. The elements that they both have in common. Number 14, B intersecting C. So let's take a look at that. B intersecting C. B is 2, 3, 4, 5, 6. C is 1, 7. The intersection between B and C, do they have any overlap? Are there any elements in both B and C? The answer is no. So that would be the empty sets. They do not have any common elements. So the empty sets. And last one. We want to do the complement of A unioned with the complement of C. So this is going to be a little bit of some work here. So I wrote A right here. I'm just going to write the complement right underneath it. So the complement of A would be all of the elements not in A in the universal set. The universal set is 1 through 10. So let's just write out the numbers that are 1 through 10, not in A. So that would be 2, 4, 6, 8, and 10. A is 1, 3, 5, 7, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So that's A complement. I think did we do C complement? No, we did B complement. So C complement, let's write that. I was right over here. So what is C? C is 1 and 7. So C complement would be everything in that universal set, not 1 and 7. So there's going to be quite a bit of some elements here. It's going to be 2, 3, 4, 5, 6, not 7, 8, 9, and 10. Just double check. C is 1 and 7. So that'd be, yep, everything else, not 1 and 7. So then A complement union C complement. would be combining these two sets together, which, believe it or not, 1 is not going to be in this set. You'd think it would be with these two massive sets, but it's not. So it starts at 2. So 2, one of them has 3, 4, 5, 6, neither one has 7, 8, 9, and 10. Remember, the union, we are putting the sets together. We're not looking for overlap, anything like that. We're combining the sets together. Those problems can get even more trickier once you get into bigger sets, like you're looking at 4 different sets, or a little bit more complicated than that, but I hope this was okay and not too rough.